morning, everyone. Good afternoon, good evening. Thank you for very much joining me and spending your time with me. My name is Tim Ward. I am the CEO here at Clued In. We help large companies become data driven, and alongside my colleagues at Clued In, we've been spending the last many years in helping enterprises solve some of the globally distributed problems and challenges with data management. And technology aside, often this can be solved with people and process and resources, and there are also times when there's the need to put different types of architectures to this. So this next 45 minutes is going to be spent on talking about what's called the Data Hub architecture. This is something that is supported out of the box with the Clued In platform. The main problem set we're wanting to solve here is how do we scale governance, data quality, data cleaning, data rules, sovereignty rules, retention policies, legislation, complex rule sets across globally distributed businesses. So let's start with the problem set itself. Let's be clear. The company data that you have is siloed and scattered globally across your business. And in many of these data source cases, many of these silos, these systems are fundamentally broken, not making it easy for you to be able to become data-driven businesses and to be able to manage and scale the data governance, data quality, and other parts of the data management lifecycle. So, to understand the landscape, let's first look at the different ways that you can manage and deploy your Clued In solutions. Now, our Clued In customers will know that Clued In is natively supported in a multi-cloud setup, in a hybrid, and on-premise. So this means that you can host Clued In completely on-premise, completely in the cloud across providers, but 95% of our customers are actually in a hybrid environment where their Clued In setup is in the cloud, but there are agents that are running on-premise on virtual machines, typically on a VM cluster, that are crunching and integrating data locally and sending it up to their cloud environment. Now, cloud templates are supported out of the box for AWS and Azure. What makes it easy at Clued In is that because we ship as Docker containers through Kubernetes as our orchestration framework, really we support any cloud provider that supports Kubernetes. So what also is known is that Clued In can actually talk across these different instances. Now we can do this from an infrastructural perspective, but what's also supported is doing this via an application perspective using API tokens. And it is worth realizing as well that from a license perspective, Clued In's licenses are very flexible. And basically, the CPUs that you purchase through your licenses are not bound to any location. And this means that when it comes to geographically distributing your Clued In instances, this is really up to your use case on how you will want to allot those licenses. So let's take a look at the Data Hub architecture. Now, the Data Hub architecture is a known paradigm. Marketing firms like, or market analyst firms like Gartner have been talking about this type of integration pattern for some time. But it's very rare to see enterprises that are properly putting this and implementing this in place. So the way to think about the Data Hub architecture is actually very similar to the way that the world operates, where we have countries that have borders, we have countries that have states or regions. Within those regions, they have cities, and to a lower level, we have towns. And actually, you can take this as many different dimensions or hierarchies as you'd like. Now, if we look at all those individual pieces or hubs, we have different rules that govern. those different hubs. But as we travel between these hubs, we need to make sure that we comply to our target so we can interoperate. So for example, if I was moving from Brisbane City in Australia to Sydney, if there are any rules that I needed to abide by to live in Sydney, I would need to be able to transform or adapt to meet those rules. And these rules are governed and gated in multiple different ways to abide by that local rules. Clued in can be set up in exactly the same manner. So let's start with some of the advantages of the data integration, the data hub architecture with Clued in. First of all, each hub you can think of as an instance of a Clued in installation. And those installations or accounts can have their own data sources, can have their own localized business rules, access control, retention policies, glossary terms, vocabularies, and more can all be locally managed. The other thing to scale this is that hubs can actually inherit these types of rules from parent hubs. So for example, we might have a city like Brisbane, which is as part of a state of Queensland. Queensland has its own rules that are governed, and those cities like Brisbane can inherit certain parts of those rules, but can override at a city level if necessary. And each of these hubs can have an allowed list of hubs that they can interact with to be able to govern things from a hierarchical perspective. Now, some of the business advantages of this starts with the fact that we can have global interoperability of data, however, with local complexity. And that is the best of both worlds. That means that at a local level, I don't need to be aware of all of the rules from every state, from every country, to be able to interop with them. I can manage my own complexity locally. And this means that hubs don't need to know localized business rules of other hubs. Hubs can also share and transform data without knowing how to do this. And hubs can be added gradually. Some of the technical advantages come with the fact that data can now reside locally. When we look around the world at some of the complex data sovereignty rules that exist, where, for example, in Germany, data really needs to reside in German infrastructure. This hub and spoke type of mechanism allows us to have data reside locally where it's necessary. Now, how do different hubs interoperate with each other? They do that via what we call the hub orchestrator. So if two hubs need to communicate, the hub orchestrator will facilitate what is necessary for that interoperability to actually occur. And what this means is that there is immense flexibility in infrastructure, where I can have hubs as granular as I want. Also, it means that there's no single points of failure in the network of hubs. A good example would be that if I needed to receive data from the London hub, that London hub might be down. But before it went down, that might have shared that same data with the German hub. The hub orchestrator will do the work to facilitate that when there are certain network nodes down in the hub network, that maybe we can ask other hubs to do the work for us. From a hierarchical perspective, what this means is that global hubs can take data from any other hub. And think of it kind of like a company. You've got global HQ, which has different regional offices. And for large businesses, you've probably got localized offices in cities. Obviously, the intention would be that global can report on the data that sits across every single business unit in their business. But also, we don't want that global HQ or hub to have to know and manage and dictate all the business rules on data that sits across at a local level. What also can be enabled through this architecture is that we can spin up brand new hubs on demand to handle complex rules. An example, once again, would be that if we need to mix data from Germany with maybe Denmark, what we might have is a rule that says, actually, when we're mixing data between those different systems, there's a rule that that must be processed in Germany. There might also be a rule that says, actually, Denmark needs to process it locally as well. So in those cases, we actually need to spin up new infrastructure in some type of sovereign third-party country where the data can be processed and potentially ripped down after that processing has been finished. Now, of course, because we utilize it clued in the orchestration framework Kubernetes, that makes this in cloud and on-premise environments very easy to achieve. So, in engineering, you could say that every up has a down. Every time we get some wins, there's always some losses that we take. Now, obviously, the big win that we get with this architectural approach is that this allows us to scale data management globally in a confident manner with the complexity of localized governance. The cost, however, that you take for this, and no pun intended, is the cost that's associated with it, the hosting perspective or infrastructural costs and overhead of having different hubs located in different locations instead of it all being centralized into one instance. However, this type of architecture really is targeted towards being able to scale globally across business. And coming with that is that this type of architecture could be seen as complicated. But to be honest, this is often necessary when we need to get wins like scaling across distributed businesses. Now, because of this, there needs to be some way for hubs to be able to talk to each other. And this is all managed through the clued-in hub e-discovery endpoint. It allows hubs to discover other hubs via what we call the hub registry. The hub registry contains lots of things like allowed lists, white lists of what hubs are allowed to talk to what hubs. And this is all with proper full access control, so we can make sure that we can control our data sharing with some type of confidence and governance. Now, we talked about this hub orchestrator before. The hub orchestrator is responsible for the transformation of data that might be necessary from one hub to another. A good example would be if in the London hub we have a quality metric or a KPI that our customer data needs to be 75% accurate. However, in the global HQ, they have a different KPI for that metric that's 85%. If we ever need to share data from the London hub to the global hub, the hub orchestrator is responsible for notifying both hubs in that communication of what needs to be done to facilitate that data transfer. And whether it's about being able to instruct the right data stewards to be able to clean the data or address those data quality issues, that's one of the ways that we can facilitate this transfer of data across hubs. This also works for distributed data cleaning, where each hub can have its own localized rules on cleaning of data. A good example would be that if in one system we have allowed values, so for example, gender, we might in one hub have male, female, and unknown as the allowed values. We might then have a different data cleaning policy that in Germany, it has to be either male or female, or potentially 0 or 1 or M or F. So the data orchestrator can even facilitate that type of transfer between different systems, and it can do this at a hierarchical level. So for example, if we have data that's in Frankfurt, and we have male and female and unknown as the options, as soon as the German hub requests, which would be a parent hub, would request the data, it knows via the hub orchestrator what needs to be done to that data to transform it into the German data cleaning rules. If then we had the global headquarters wanting to get that data from Germany and in turn from Frankfurt, it might have its own data cleaning policies as well. Once again, this is the responsibility of the hub orchestrator. And this also goes for the quality metrics and KPIs. Localized quality metrics can be set to share to be able to cover local legislation and requirements and regulation. As you move this data throughout the hub network, you might find that there are lower and higher KPIs. Once again, the hub orchestrator will do the work to facilitate who are the people, whether it's manual data stewards or whether it's data engineers, to be notified of what work needs to be done to be able to have that data transfer. Now, if you've seen our eventual connectivity webinar before, you'll know that this also allows us to scale the merging of data across different accounts. Now, how do different hubs talk to each other? Different hubs talk to each other generated by API tokens. That is the default way that two different hubs can talk to each other and transfer data. The good thing about utilizing the API tokens is this allows Clued to track the data lineage and audit trail of what data has flowed in between the hub network and what data has been shared. And of course, this is really about, at the end of the day, enabling stewards of data to be able to increase the overall governance and data quality of data flowing throughout a business. And utilizing the hub orchestrator, essentially, if we find that there is a data transfer that is happening between hubs where there is no known rules of transformation, a steward can either create those rules of transformation, or they can be given sandboxed environments to be able to address those transformation issues. If, for example, it's something as simple as being able to transfer data between two different hubs that have different KPIs on data quality, this can do that orchestration to involve the right data stewards that are connected or are the owners of that data, and facilitate them with tools within Clued to do their work to increase that level of quality so that data transfers can be done and still abide by the overall governance that exists in this hub network. So this is great. Now we can have global HQ that can set overarching rules of governance. Regional hubs can do the same, and local hubs can do the same as well. But what this means is that global HQ doesn't need to know about all the localized business rules. This is one of the reasons why data governance by itself is very hard to scale. But utilizing this hub architecture, this allows us to achieve this. I'll give a simple example. If we found that in the German hub, we had our customers in a CRM system, and we had a rule that was built locally in Germany that said, if the customer name starts with DEC, that there is a scheduled job that will run every 5 days that will remove this record from the system. It is highly likely that this will not be a global rule that every other hub will also take on. It's also highly unlikely that when this rule was put in place, that every other hub was actually told that you need to watch out for this certain data. The hub orchestrator is there to be able to cater for these situations. where as long as the German hub sets up a data policy that alludes to this type of mechanism or business rule in the data, the hub orchestrator will take care of the rest when we need to share this data across different hubs. Now, in times of sensitive data sovereignty, so of course, the different data privacy acts around the world meant that we as businesses need to take into consideration where our data is hosted, especially in globally distributed businesses. Now, the great part of this is we can set up these rules within the Clued-in platform, and actually Kubernetes, that orchestration framework for infrastructure, can be used to spin up localized instances in an allowed environment and integrate the data and, if necessarily, tear that same environment down once the work is done. So having governance in place, even from an infrastructure perspective, and where the data is hosted can be managed with this type of data hub architecture. Of course, access control supports hierarchy within Clued-in, and of course, this also this also plays a role when we're talking about how different hubs interrupt with each other. Now, of course, it would go without saying that the data lineage features of Clued-in are also hub enabled and hub aware, where we can track from different hierarchies of hubs where data is either regionally or locally being transferred between different hubs. This gives us that full traceability and full lineage of how data is moving throughout your entire global business. And all of this complexity is abstracted away when you actually want to use the data out of your Clued-in hubs. Whether you want to get the data out at a global level, GraphQL is there from the Clued-in perspective to be able to abstract away where that data came from and just to work with your data as one unified set, not having to look at the underlying complexity of that hub network. Now, it is worth mentioning that currently in our product, our data catalog is only supported at a per hub level. And it is on our roadmap to be able to add this support in so that you can have a hierarchically distributed data catalog that caters for the different terminologies that exist in the different regional or localized hubs. Now, for those of our customers that utilize our Mesh API to be able to write back our good, clean, quality data to the source systems, you'll be happy to know that this is also supported across hubs. Imagine being able to change the address of a company from a global level and have all that work of writing back to all the localized hubs and their source systems all managed in a kind of a mesh framework or network. This is all supported through this hub architecture. And to summarize, this is how you scale data management across globally distributed businesses in a manageable way. The data hub architecture allows us to manage our data from a governance perspective, from a quality perspective, from a compliance perspective, from an overall umbrella of data management perspective, as if we were only looking after one localized hub, but in a way that can interop globally with a full complex mesh and network of different hubs. And let's be honest, for the largest businesses in the world, this is exactly how they are built. Globally distributed with localized rules that dictate their own hub policies. This is how you scale data management across globally distributed businesses. And thank you for spending the time with me.